Vanakkam. Welcome to this video on biomechanics. In this video, we will be looking at kinematics of a 3-link kinematic chain. Specifically, we will be performing a velocity analysis of a 3-link serial kinematic chain or a 3R manipulator. So, consider a 3-link kinematic chain. Okay. There is theta 1, theta 2 and theta 3. Right. From forward kinematics, I can find the endpoint coordinates of the point P as x is L1C1 plus L2C12 plus L3C123, right, and the y coordinate is L1S1 plus L2S12 plus L3S123. I differentiate this with respect to time. X dot is minus L1S1 minus L2S12 minus L3S123 times theta 1 dot plus minus L2 S12 minus L3 S123 times theta 2 dot plus minus L3 S123 times theta 3 dot. Right. Likewise, y dot would be L1C1 plus L2C12 plus L3C123 times theta 1 dot plus L2C12 plus L3C123 times theta 2 dot plus L3C123 times theta 3 dot using chain rule. I request you to please spend a few minutes and check if this is correct. It is correct, but please check, please do the math on your own, please write out this entire differentiation and practice once. So, you are convinced that this is indeed correct, this is correct, but please check. Okay. So, we did a similar equation in the previous video and we wrote out the Jacobian in that case. So, let us write out the Jacobian in this case. What is a Jacobian in this case? Will it be a square matrix? The answer is no, because there will be 3 columns and 2 rows, right. There will be 3 columns and 2 rows. That would be minus L1S1 minus L2S12 minus L3S123 minus L2S12 minus L3S123 minus L3S123. Here L1C1 plus L2C12 plus L3C123 L2C12 plus L3C123, here L3C123. There are indeed 3 columns and 2 rows. This is not a square matrix, right. So, remember, forward kinematics is a problem that is meant for solving at the school level, high school level, college level, undergraduate level. Real world problems almost always involve inverse kinematics, solving for inverse kinematics, right. So, real world problems, when they involve solving for inverse kinematics and I have an equation, I have a Jacobian that does not have an inverse, because this is not square, the Jacobian matrix is not square. So, there is no J inverse is not defined for this case, for the 3-link kinematic chain, right. Then, but I am still interested in finding the particular joint angle velocities, given that there is a known end effector velocity for a particular task, for a particular configuration. Let us say that there is a configuration, I know the configuration, and I am interested in finding joint angle velocities given that this is the end effector velocity, given that this is the end effector, can I find this in this case? It turns out that there is a way to find it, but this is not a trivial problem. This is not a simple matrix inverse problem like we saw in the 2-link serial kinematic chain problem. So, we can find the inverse of a 3-link kinematic chain Jacobian, but it is a non-trivial problem, right. That is, in other words, I am interested in solving for this, the theta equation as the J inverse times x dot equation, is it not? All these are matrices. I am interested in finding this, but I can't find this. Why? Because J inverse does not exist, right. J inverse itself does not exist. Now what to do? That is the question. That is the problem that I am faced with. And this is only the 3-link chain. There are many more chains like this, no, 4-link, 5-link, 6-link. So, there are redundant manipulators with many links that are there, all of which will not have a square matrix as a Jacobian. Now, the question is, can I find a general way in which I can use to find the inverse somehow, right. It turns out that there is such a solution. That method is called as the Moore-Penrose pseudo-inverse method, which is essentially J plus is J transpose times JJ transpose the whole inverse. Remember, this is not the Jacobian inverse, this is a pseudo inverse, right. When you say pseudo something, that is not real, right. So, this is not comparable to the J inverse that you got in the 2-link case, right. The J inverse that you got in the 2-link case is an exact solution, right. It exists, and it exists at each configuration. In the 3-link case, what you are finding is a pseudo inverse, remember this. So, J inverse in this case is different from the J inverse that you got in the 2-link serial kinematic chain case. This is some form of a, let us say that this is an analytical trick, this is a trick to make it work, we are forcing it to work, okay. This is the so called Moore-Penrose pseudo inverse case. So, in this video we saw the velocity analysis of a 3-link kinematic chain, the forward kinematics. So, in other words, we defined x dot and y dot in terms of theta 1 dot, theta 2 dot and theta 3 dot, and we also saw how we can use a special method called as the Moore-Penrose pseudo inverse technique to find the inverse of the Jacobian for the 3-link case for non-square matrices. Remember that this is not an exact method, this is an analytical equivalent. So, this is a form of a mathematical trick, right. So, with this we come to the end of this video. Thank you very much for your attention.